Hi class, welcome back. Hopefully you enjoyed all of the graphing. Today we're going to move on to a different section. So what you should know about quadratic functions, the kind of big picture of this whole entire chapter, okay? I'm going to start us off with an example to kind of work into why we're doing what we're doing. So if I give you the equation 17x plus 9 equals 60 and I said to solve for x, what would you do first? Hopefully you said subtract 9. So you would subtract 9 from both sides. And then 60 minus 9 is 51. Ooh, that was ugly. 5. And then you're left with 17x on the right side. And so then it's 17 times x. So to undo that, divide by 17 on both sides. And 51 divided by 17 is 3. So really there was only one way to solve for x in this problem. And what we're going to find today is that there are several different ways to solve for x if you have a quadratic function. So as you noticed in the graphing portion, there were 3 different forms of a quadratic function. Let's review what those are. We had our standard form. So standard of a quadratic function was y equals ax squared plus bx plus c. And then we had vertex form. And vertex form was y equals a times the quantity x minus h squared plus k. And then we had intercept form, which was y equals a times x minus p times x minus q. So if I were to give you any of these 3 forms and said solve for x, well, there's lots of different ways to do that. And so the very first method that you actually already learned to solve for x is by graphing. And so if we were to go back and look at some of the graphs that we did together, if I asked you to solve for x on this graph, the intercept form, basically what I'm asking you to do is to tell me where that graph is crossing the x-axis. So that is super important. With any quadratic function, where the graph is crossing the x-axis, those are your x values. Those are your answers, basically. So if we look at our graph for this one, this graph was crossing through the x-axis at negative 2.5 and negative 0.5. So those are our 2 x values. So going back to that equation, if I said solve for x, right now you don't know how to do that because I haven't really taught it to you yet, but eventually you would get negative 2.5 and negative 0.5. If I go to a different example, one that was not intercept form, if we go to this vertex form graph, here's your equation, and then over when we graphed it, actually that's not a good example. Let me go back to the first example for vertex form. We had our negative a, negative 3h value, and positive 4k value, but these 2 spots where it's crossing through the x-axis, negative 5 and negative 1, those are the x values. So we solved that quadratic by graphing. This one, since they're not cutting through at exact points, this is one that I skipped, we would have to choose a different method because graphing isn't as accurate. It's not an exact point where it's crossing through. So we wouldn't want to use graphing to solve this quadratic function. We want to use another method. And so today I'm going to teach you another one of those methods, and it's called factoring. So right there. Today is the first lesson in factoring. There are, I believe, 5 different lessons in factoring, so there is a lot for factoring, but it's not that difficult once you get the hang of it. It's very repetitious. And so part 1 today, we're going to start, this is after the sheet of graphs that you were supposed to do on your own, and it says part 1 FOIL method. So if you have a colored copy, it's in blue, solving quadratic functions by factoring. So this is technically the second method to solve quadratic functions. The first method was graphing, second method is factoring. All right, so first of all, you need to know a lot of vocabulary in this one. The FOIL method. So FOIL means first, outer, inner, last. You also might think outside or inside. So first, outer or outside, inner, inside, last. FOIL. And what that is that's a way to remember how to multiply something. And what we are multiplying, if you look at example 1, are two binomial expressions. So what does the prefix bi mean? Like in bicycle. It means two. So two what? Nomial. What's a nomial? My 2nd through 5th period, we were already over this, but a nomial is like a term. So if you look at this, first example, x plus 3. That is a binomial because it has two terms, one term, two term. And it's being multiplied by another binomial because there's one term, two term. So a binomial times a binomial. FOIL is a method to help you how to multiply those. So really what I want you to understand is that FOIL is just another method for using the distributive property. Okay, so you're multiplying things together. It's kind of like distributing. So the first of FOIL refers to the first term of each binomial. So first times first. I like to draw little arrows to see what's being multiplied by what. And so x times x is x squared. So that's your first. The outer is taking the two outermost terms. So that outer x here with that outer 6, and you're multiplying them. So x times 6 or 6 times x is 6x. The inner part is talking about your two innermost terms, so it would be that 3 and the x. So inner would be 3 times x, which is 3x. And then the last part of FOIL, L, is doing the last term times the last term. So the 3 times the 6, which gives you 18. And then what you should notice in this expression is that you have one x squared term, a 6x, a 3x, and then a constant term, 18. So what should you do with those two x terms? Combine them. So I have a positive 6x plus another positive 3x for a total of 9 x's. So x squared plus 9x plus 18 would be your final answer. So a couple different things I want to point out to you here. What you're doing is you're multiplying. Like I said, this is a way of distributing. So FOIL, you're taking that first term and multiplying it by the two terms in the other bubble. And then you're coming back and taking that 3 and multiplying it by the two terms in the other bubble as well. So everything's getting multiplied by everything else. And then FOIL is just a way to help you remember that. First, outer, inner, last. And then you will have to combine your like terms, and then your final answer is that. So if you notice, if you think back to the graphing portion, what we started with, if I were to just say y equals this, what form is that in? Hopefully you can see that. That's in intercept form. So then when we FOILed it, now what form is it in? It's in standard form, okay, with the ax squared plus bx plus c. So that's one thing you should know. I want you to do B on your own. I'm going to highlight it. You're doing B on your own. Try that one out. I'll do C with you as well. So C, there's some more numbers thrown in there, different signs. So first, outer, inner, last. You're multiplying a binomial times a binomial. So first would be 4x times 5x. You're multiplying. So 4x times 5x would give you 20x squared. Because that x times x gives you x squared. It's being multiplied by itself. The outer is that 4x times the negative 3, which gives you negative 12x. Inner is 7 times 5x, which gives you negative 35x. And then the last would be your 7 times negative 3, which gives you negative 21. So then again, combine like terms. You only have one x squared term, 20x squared, negative 12x minus 35x gives you negative 47x, and then your minus 21. Okay, so that would be your final answer. Okay. Example D, 9x plus 5 squared. What do you think we do with that? Do you think we just get 9x squared, which would be 81x squared, and then 5 squared, which is 25? No. And why is that? Any idea? What does it mean to square something? Squaring something means multiplying it by itself. So really, that's wrong. What we're multiplying is a 9x plus 5 times another 9x plus 5 binomial. So that bubble is being multiplied by itself. So you must FOIL this. If you don't FOIL it and you just square both of those two terms, you get the wrong answer. So let me show you what you should get by FOILing. Your first 9x times 9x does give you an 81x squared, but your outer and your inner are both 9x times 5. So 9x times 5 is 45x. But then the inner, 5 times 9x, is another 45x. And then your last, 5 times 5 gives you 25. So when you combine your like terms, you get 81x squared plus 90x plus 25. Okay, so you have a whole middle term there, that 90x, that you're missing out on if you just multiply or raise both of those terms to the second power. Where we might have seen something like that before is when we talked about our properties of exponents. If you had 3x squared y all raised to the 4th power. Here we did raise everything to the 4th power, and then a power to a power, you multiply. We did that because this was all multiplication, okay? Everything inside this bubble is being multiplied, so we could just raise everything to that power. But over here, there's an addition sign. So if you're adding or subtracting, you have a binomial. You don't just raise everything to that power. You must FOIL it, okay? All right, so that FOIL method was one way of multiplying two binomials. But I'm also going to teach you another method, which I call the box method. So this is the same exact thing. It's just a more kind of organized way of doing it. And so if you love your Punnett squares, it's just like a Punnett square, except you're multiplying. So if you have two binomials, x plus 6 and x minus 2, two terms and two terms. So you have a 2 by 2 or 4 box. Your first binomial bubble, the x plus 6, each term gets a box, okay? And then your second binomial bubble, x minus 2, that goes along the side. Make sure you're grabbing the signs that go along with the terms. So now you're just multiplying. X times x. Those two multiplied together give you x squared. And then x times negative 2 gives you negative 2x. X times 6 right here for this box gives you 6x. And then 6 times negative 2 gives you negative 12. So inside the box, now you must combine your like terms. Typically, not always, it will be these diagonals right here that combine. Okay, because you have your x squared right here. And then 6x minus 2x or negative 2x plus 6x, when you're combining them, you get a positive 4x, and then your minus 12. And there's your answer. So again, this is another way to do the same thing. You're multiplying two binomial expressions and getting a trinomial as your answer. And I don't care which method you do. Okay, whichever one you're more comfortable with is the one that you should do. I want you to do example A by yourself. Okay, try that one out by yourself using the box. I want you to do example B well, actually I'll do b with you. So again, you have a binomial times a binomial. If you make the box, that's a terrible box. Okay. Better. Okay, 3x plus 1. 3x, positive 1. 2x minus 4. 2x minus 4. And you're multiplying them. 2x times 3x is 6x squared. 3x times negative 4 is negative 12x. 2x times 1 is 2x. Negative 4 times 1 is negative 4. Now that you filled in the box, combine your like terms. Again, it's usually that diagonal. So you have your 6x squared. Negative 12x plus 2x is negative 10x. And then you've got your minus 4. Done. Okay, so multiplying binomials. I want you to do c on your own. Okay, remember you have a binomial squared. So you should be multiplying 2x plus 6 times 2x plus 6. Don't forget to use the box. All right, number 3, write the quadratic equation in standard form. So if you look at it, what form is it in right now? Okay, we had our 3 options over here. What form is number 3 in? Hopefully you said vertex form. So what you're going to do, follow order of operations. First, your parentheses. Well, there's nothing to do inside of the parentheses, so next is exponents. Ooh, we got an exponent. So we need to square this x minus 2. So I'm going to come over here, and I'm going to use the box method. And so we have x minus 2 times x minus 2. So x times x is x squared, negative 2x, positive 4. And then that gives us x squared minus 4x plus 4. So really all I've done is just taken this part right here and squared it. And then I got this as an answer. But if I notice there's more going on, it's times 4 on the outside there and then plus 5 on the end. So order of operations means we need to do what next? We just did our exponent, so next we need to do multiplication, which 4 is being multiplied by all of this. So we must distribute the 4 to every term inside of that part that we just squared. So that then gives us 4x squared negative 16x plus 16. And then we still have that plus 5 tagging on at the end. So that's the addition part, order of operations. Now we can combine like terms, which we have a positive 16 and a positive 5, which gives us 21. So y equals 4x squared minus 16x plus 21. So we went from vertex form to standard form. Okay? So knowing how to FOIL or use the box method, you can go back and forth between the different forms. So next, I've given you one that's in intercept form, and I'm asking you to put it in standard form. So basically, you need to multiply those two binomial bubbles. And then once you have that multiplication done, then you can multiply by your negative 1/2 out in the front. You could multiply by negative 1/2 first, but it would only be to this bubble. That's like saying 2 times 3 times 4, okay? You can do 3 times 4 first, and then multiply it by 2. You could do 2 times 3 first, and then multiply it by 4. You could do, yeah. So it's kind of the same thing here. You can do your negative 1/2 times this entire bubble, and then multiply that times x minus 8, or just multiply your two bubbles first, and then multiply everything by negative 1/2, which would probably be easier. So I want you to try that one on your own. I'm gonna highlight it, maybe. Pen stopped working. And also C, I want you to try that one on your own. So you're gonna do B and C on your own as well, writing them from their current form into standard form. Let me know if you have any questions in the comments, or you can email me, and we will do part 2 next. I hope you have a great day. Again, I miss you all, and I hope you're doing well. Don't be afraid to send me an email or a comment. I would love to read it, to talk to you guys. So have a great day.